Huh? Okay. You have to learn how to use tables, and you have to learn what the aspect of it. Tables always give you two things. They give you a score, and they give you a probability. And sometimes we want if we have the probability, like if I'm talking about the Z table. Whoops. Where did the Z table go? Okay. If I'm talking about the Z table, what are these in here? No, these are not the Z scores.
Everything to the left.
What's everything to the left?
95%.
And the 95% is the?
Third quartile?
No.
Probability.
It's another word that starts with P.
Wait. I'm from
Percent?
somebody else.
No.
Probability.
Probability. Okay.
Thanks, probability.
So, see, so these are the probabilities that something is below a certain score. So if I'm looking at it, these in here are my probabilities. The numbers that I have down along the side and across the top are the actual Z scores. So if I have a Z score of 2.3, say I have a Z score of 2.31. So if I'm looking at that, and I just say I have a Z-score of 2.31, okay? That means that if I look at that and I go to 2.31, I'm right here, what that means is that 98%, 98.96% is to the left. So that means I have a probability of I have a 98.96% probability of being less than 2.31. If I had a Z-score of 1.7, if I had a Z-score of 1.76. I can look it up and go 1.76, and I would say that I have a 96% chance of being less than 1.76, because that means I'm on the left-hand side of the table. Now, if I sit there and say, what's the Z-score associated with being 90% less? Okay, if I want a Z-score for being 90% less, that means I want to find 90% in here. So if I look at this, 90.9, 90, 90, 90, 90, 32, 90, 15. So if I look at this, I get 0.9015 here and 0.8997 here. So 90% is somewhere in between. It's somewhere in between 1.18 and 1.
No.
1.1. My eyes are crossed.
1.8, yeah.
1.28. That ain't right either.
1.18.
Wait,
I'm on the gray bar,
98?
and I want to be between 90.
Oh, how come yours is different?
Okay. So I'm in the white bar. So 0.8997 is 1.8 and 1.2.
1.2.
Yeah. So if I'm looking at that, 0.90 is somewhere between 1.28 and 1.29. So I have to play with this. I don't have it exactly in the table. I don't get a pen. It was working fine up until I wanted it.
Still not right.
Huh?
Oh.
There it goes. Okay, so I want to know when I want to know the z-score that's associated with 0.90. But I can't find 0.90 in the table. What I found was that I had what was it? 97, which was 1.28.
Wait, 899. Sorry.
And then I had 0.9015, which was 1.29. So the z-score I want is somewhere between 1.28 and 1.29. If I'm using the table, that's the best I can sort of do.
But he says you choose the one that's closer, right?
I would normally choose the one that's closer. So I could choose 1.28. Okay? Actually, I'm going to show you a couple of things. Now, if you're doing it on a test, I would probably use a table or a certain aspect. If I want to, I can actually go to Excel. And if I'm using Excel, I want to find in this case, I'm trying to find a z-score. And this is why you have to understand, am I looking for the z-score or am I looking for the probability? So if I'm trying to find a z-score, okay, if I click on here, it says more functions. What's another name for the z-score? No. What's the name of the table? What does it call it?
Standard normal.
Repeat that.
Standard.
Standard, normal. Okay, so we talked about that. So if I go in here and I start looking, and I'm going to click on the statistical functions, just so I don't have to go through a lot of different functions, I can scroll down through here, and you will see that there is an area here where I've got some things that say what? Normal distribution, normal inverse, norm S distribution, norm S inverse. So I've got 4 different functions that sort of say norm. I will be honest, I don't remember which one's which. Okay? Now, if I look at this one, and I'm looking at the normal distribution, what does it say it returns? Returns the normal distribution for a specified mean and standard deviation. So remember, when we talk about that, how do we calculate the z-score?
Use the
X minus X bar
Square.
divided by,
And
nope,
standard deviation.
standard deviation. Okay? It's some number minus a mean divided by the standard deviation.
that's for the regular z-score.
That's how we calculate a regular z-score. So when I look at this, what does this say? It says returns the normal distribution for the specified mean and the standard deviation. So if I sit there and I click on, whoops, where'd it go? And I click on that, if I put in a mean, what was that one we did? If I click and I put in a mean, whoops, I put in my score, say, now I gotta have some information. I can't do this.
I don't,
So I'm going to do this, I'm gonna have you look it up in the table real quick. So if I told you that the mean was 5.8 and the standard deviation was, say, 0.75, and I gave you a score of 7. What is the z-score associated to that 7? So how would I do that? I would be what? 7 minus 5.8 divided by 0.75, and what would that, go ahead and calculate that, and what do you get?
oh yeah, I see it now. Divided 1.6.
So if I wanted to calculate that, we get 7 minus 5.8 divided by 0.75, which gave us what?
1.6.
So the z for the score of 7 is 1.6. And that's nice. So if I did that, and see, I plug this in, so my x is my score, which is what in this particular example? In this example, what's my x? 7. It's the score that I'm looking at. My mean is 5.8. And my standard deviation is
0.75. How'd you get that table to come up? I can't get mine to come up. How'd you get that? When you typed that in, it just came up?
I clicked on the down button and pulled down my formulas.
Formula?
It won't come in when you type it.
Formula builder?
Insert.
Insert?
And you're using an Apple, so I don't know how it really works on an
And
Apple.
then it'll be over here.
What will be over?
Your normal.
Oh. No, it just came up like that. Oh, that's weird.
See, apples are a bunch of junk. Get rid of, move someplace else and get rid of that. Okay. Come up here where there's some sort of button that says function.
Function?
Or formulas.
Formulas, got formulas. And then got insert, got formula builder.
Yeah.
Got insert.
Okay. I'm gonna have to go look at it because I don't know how it functions, so after class or whatever,
Okay.
I have to look at that.
Yours needs the
Is
older
it a
version.
normal?
Because mine has
Is
it.
it NORMSDIS?
Oh, I need to get me a newer version if that's the case. What?
When I showed you, there was,
Formula
see, this is why you have to understand how to work a table.
Now, tell
Because
me.
there are multiple formulas.
Oh.
And it depends on what version of Excel you're using. Okay?
I got it, Bob.
So I can't answer all those questions because it depends on what version of Excel you're using. But you sort of look at it, and here's where you have to sort of be able to use the table. Don't rely on Excel, rely on that. Because you see that there's one more box down here that says cumulative. And when I click on cumulative, it says that I either have to enter the word true or false. And I will be honest with you, I don't always remember.
Huh.
Okay, now, this, if I'm giving the mean, I think it should give me the z-score, right? Well, we just calculated it, and we know that the z-score should be 1.6. So if I type in true, it gave me 0.9450. Did not give me 1.6. What did that give me? It gave me the probability. It gave me the number from the part of the table. So what it's saying is, that's the value where 95% is. Okay? Now, if I go back on that same box, and instead of writing true, I write false, it gives me 0.147, which is the area to the right. So if I use this, it gives me the probability that I am to the left or the probability that I'm to the right. It doesn't give me a z-score, does it? Okay? So when I look at this and I use the formula norm distribution, it gives me the value from the table. See, this is what I'm saying. I don't remember which formula. I don't have a memory big enough to hold all this stuff.
Well, maybe we could look it up or something.
But I clicked on that, and what did I get? I got the probabilities, right? So if I go back in here, and I click on this, and I come down here and say more functions, and instead of using norm distribution, I use norm inverse.
Norm inverse.
And I sit there. Now it says they want the probability and the mean and the standard deviation. And this is where I got to understand. This will actually give me the z-score. So I got to be careful. See, even when I use Excel, I don't remember exactly which one I'm doing. Okay? I don't remember whether I'm using the distribution or the inverse. One is I look up the numbers in the middle, and one I look up the other value, so I have to be able to go back and forth. So even though Excel will look it up for me, I don't trust Excel, because I never remember exactly which one of the two formulas are without testing it against the table. So I never use Excel without having a table handy to make sure that I'm using the right formula. Does that make a little bit of sense? You can do it with, now, remember a lot of times you say you come up with something that's just a little bit different than what I do. That's because when I use Excel sometimes, okay. Okay. When I use norm S distribution, it says type in the z-score, so I type in the z-score of 1.6. Is this what I'm doing? And cumulative. Actually, see, I don't tend to use these to find the z-scores. I will tend to use them to find the values backwards for the tables. But the z-score, I just calculate straight like this. So I'm not that worried about using one of the formulas for doing it. Because to me, it's harder to remember which formula to use. Okay? But when I'm looking at things like and I want like the 95th percentile, and I want to look up the values And this is where this comes in, and I can actually do this norm distribution. Whoops, wrong one. Z is the value I want the value for. I want going inverse. And I type in that I want the 0.95th percentile. And I click on OK. And see, it gives me a Z-vet score of what? 1.644853627. When we just did it and looked it up, we used 1.645, didn't we?
1.6. Oh yeah, for the other one.
Okay, when we looked it up in the table and we found it, we used 1.645. When I used technology, what did they do? They're a little bit more accurate. They use 1.64485. So you know, sometimes you say, I'm off by 1/10 or 100%. Because see, if I use technology to get the Z-score, I might use a little bit more accurate Z-score than what you're using from the table, which will make our answers off by 0.1% or something. So you always have to be careful when you're doing things. So if you use technology as opposed to using a table, it can give you a little bit off difference. The example that we just did a minute ago where we were doing what? We wanted to find the Z-score for 0.9, and we looked it up and we said it was between 1.28 and 1.29. See, if I use Excel and I click on this, and instead of finding 0.95, I'm trying to find the Z-score for 0.90. See, it gives me 1.2815515566.
How are you doing that?
Which is somewhere in between these two numbers, right?
What's he getting?
So if I use technology to find my Z-score, it will give me a more accurate number. If I'm using the table, I'm just going to use these. This is why I say, depending on how you find your Z-score, you can get answers that will be slightly different.
That's it?
And I can't guess every possible way that you will do this to get a Z-score. Okay, so whether I use a table or I use technology, see, here we found that 0.9 was somewhere between 1.28 and 1.29. When I use technology, it said it was 1.28155, which is just slightly above 1.28, right? So what did we say? When you're using the table, use the one that's closest. Now, some of you might get energetic enough. If you guys go out on the YouTube and they say, go look at, use Excel to find it this way, you might find a more accurate version of the Z-score, which means your answer will be a little bit different. Yeah. It won't be exactly the same because you used a more accurate Z-score than the table gave you. On the internet, you can go to the internet. And I clicked on the wrong. And on the internet, oops, I didn't want that one. Where'd it go? There it is. There's a web page called davidmlane.com. What does this curve look like? Normal curve. Has a mean of 0 and standard deviations of 1. And then down here it sort of gives me some information, but it gives me the ability to use the table in both ways. I can either enter the mean, the standard deviation, and the actual values, or I can ask for it to find the area, which is the probability. We were just trying to find the z-score for an area of what? What? The z-score for what? What did we just find it for? What z-score were we finding? For 0.90. We found it in the table, right? And it was between 1.28 and 1.29. We found it using Excel and it was 1.2815 something da 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 da, right? Well, I can use his thing and I can sit there and say, I want to find the area for 0.90. Whoops.
0.90.
I thought I could do it backwards. Maybe I can't use this table backwards. Maybe I can't use this table backwards. I can use this one backwards. Okay, I can't use his tables backwards. I thought they did work backwards, but I guess they don't. Okay, but using technology, you might find different values. So depending on what you do, you can play with these and get some different aspects of that. Bronson, what was the other question you gave me earlier? The one where we had to find, where it gave you a value and it says, find it between, what was it,
3.5 and 4.25.
So you remember this was the one that said the mean was 4 hours. It said that the standard deviation of X was 1.2. And it wanted to find the probability that the number of hours was between 3.25 and 3.5.
I think it was 3.5. 3.5.
And 4.25. And it wanted us to find this probability here. Right? Using the table, and this is where some of the aspect behind it is using the table. What do I have to do? Whoops. I have to take the probability of it being less than 4.25 and subtract from that the probability of being less than 3.50. I want to find this, which means I have to find what? Because if I'm using this normal table, what do we have to use? The normal table is based on what type of scores? Z-scores. Because remember, it wants to use when the mean is 0 and the standard deviation is 1. So we have to be able to convert these. So I've got to go out and find some z-scores. So I need to find the z-score related to 4.25. How do I calculate that? Z-scores are always calculated the same way.
4.25 minus 4.
4.25 minus 4 divided by,
0.3.
where does 0.3 come from? We always have to divide by some sort of form of standard deviation. Now this is where it gets tricky. And this is where the central limit theorem comes in. What is this the standard deviation of?
The,
No. It's the standard deviation of the population. What is this the mean of?
the
The
population.
population. And they were given to us in the problem, right? It gave us, it said, historical data told us that the mean was 4 and the standard deviation was 1.2. But now we are looking at a sample of 16, right? So we're looking at sample data. And we want to sort of know about that. Now, the aspect behind it is the mean of the sample data is still going to be 4.
Yeah.
But the standard deviation of the sample data is what?
Is the variable, the count
The standard deviation of the
over the
population divided by the square root of
count.
the sample size.
Yeah.
So in this case, it gets the 1.2 divided by the square root of 16, which is your 0.30. See, you gotta be aware where this comes from, because it's, I got 2 standard deviations, right? Which one do I use?
That's the standard deviation of the population. That's the
That's
standard.
the standard deviation of the population X.
That's
This is
standard
the standard
deviation
deviation of the sample
of the
means.
Sample means, not the
Yeah,
sample.
let's see, X bar is the mean, right? This is the standard deviation of the sample means.
Yes.
This is why I was being such a, about trying to make sure that you understood symbolism in the first half of the semester. Because I knew we were going to get into where we start using these and we talk about a lot of different things. And if you're just sitting there saying, oh, whatever, you're going to be in trouble because you gotta understand it's this aspect of where they're coming from. So when I look, so I'm going to take this, so it's going to be 1.2 divided by the square root of 16. And when I do that